tree looks quite interesting. I'm going to go through this one fully, and let's first look at the shape, and we can infer something. Once again, we have our subtending segment friends. I'm going to indicate these, and we have between A and C. We have subtended, or we can draw a segment. Between D and B, we can draw a segment. And so once again now we see that angle A here is going to be equal to X. So I'm just going to indicate that with the same line. And we know that because of being subtended by AC, or the segment AC, I know that Y is going to be equal to Z, the two angles here. Okay, so we have got two angles. But now we have a strange outlier. We've got this third angle over here, angle P. And he doesn't seem to be playing nicely because he's totally outside the picture, or outside the circle. So let's see how we could consolidate this. We're trying to get unknowns, Y, Z, and X. Now, X is fine enough. And we know that these two angles are equal, but they're both unknowns still. So one might think, well, how are we going to do this? How are we going to manage to find it? These unknowns. And it must do something with this external triangle, or this external angle over here. And the first thing we can see, if we look at it hard enough, and this is why it's nice to take the time to study a picture out through. And you often have these duh moments where you really couldn't see something and then eventually you end up seeing it. It's just, you try and see everything. But I'm going to point out to you, we actually have a triangle. With this external angle, we have a triangle which is the same as P, or which is PBA. Okay? So there's this triangle that is actually running, if you look at it, all the way along. It's a large triangle. And what's the benefit of that? Well, within this triangle, we now have two angles, and we're just missing the third one. Okay? And that third angle is going to be this angle over here. Whatever one we look at. Okay? And that we're going to find is going to be useful, because we know that CP is a straight line, and we have a formula for working out, well, we know that the angles on a straight line add up to 180 degrees. And so we're going to be able to quite easily work out what this angle is. Okay, but I've drawn a lot on here. Okay, so let's quickly erase everything, and let's begin with that now that we've seen the similarities, or now that we've seen some things on the board. Okay, so we've erased most of the markings from our triangle, but now let's get into the maths. Okay. The first thing I'm going to say is, when looking at this, that angle A equals X, or angle X, and we know this is theorem 3 again. Both angle A and angle X are subtended by the segment DB over here. That's just slightly up in the picture, as we can see. Okay, so we now know, so that's going to be the reason angles in the same segment. Theorem 3, and that segment is DB. So I now know that therefore angle X equals 20 degrees. Okay, I'm going to pull that out quickly. So I've got another 20 degrees. Perfect. So having known that now, let's look at what other unknowns we can find. I spoke about looking at triangle APB as one big triangle. And so let's quickly see how we can extend this. I know that one of its angles is 20, the other angle is 30, and so angle B over here, if I define angle B, I can write, if I'm looking for it, let me call this B1, okay, I know that angle B1 is going to equal 180 degrees, the angle sum of the triangle. It's going to equal 180 degrees minus 20 minus 30 degrees. Okay, and so from that we have the triangle going to sum up to 50. It's going to equal 130 degrees. Okay, that's really nice. So this is just a standard angle sum of triangle. And this is triangle APB. Okay, great. Now, from that point onwards, we can now say that angle Z must equal 180 degrees minus angle B1. Okay, and that makes sense. They're on a straight line over here, these two angles. And we know that angles along a straight line always add up to 180 degrees, which we have at the bottom here. And so from that, we are going to say that Z1, or angle Z, must equal 180 minus 130, so it must equal 50 degrees. Okay. And that's really nice now. So we have Z equals 50 degrees. And, well, it just falls straight out from there, but now our last unknown, y, we can easily get, because we have angles in the same segment. Whoa, sorry there. From this, now I can say angle y equals angle z, which was 50 degrees, so it equals 50 degrees, and this is once again angles in the same segment. Okay, and once again, this segment now is segment AC. And there you have it. Well, there's the math for today. And these problems, they just take a bit of looking into, but they're relatively straightforward when we do examine them enough. Main thing that I'd like to point out in maths is always providing reasoning, because that's where you get a lot of your main marks from. Well, actually all the marks, unfortunately. Yeah. And the main thing is also seeing where your theorems can apply and seeking to apply them always. Makes sense. Hope you have a great day, Mikey. Cheers.